And I'm Ben from danthemathman.com. Welcome to this tutorial where we will give helpful and easy insight on simplifying radical expressions.
Although simplifying a radical expression looks daunting, it's quite simple when you follow easy steps.
Radical expressions are represented as a monomial, binomial, or polynomial under a square root. One important rule is that everything must be simplified, and when we learn to simplify the fractions, you are unable to have a square root in the denominator.
When starting out with simplifying radical expressions, an easy way to start out is to use the half-power method.
We say half-power method in quotations because it's not so much as a method, but more a different interpretation as an existing method.
First, we will start off with the easiest problem available to give you an idea of how to simplify the radical expressions. In general, square roots in the math world are seen as multiplying a number by the half power. Also, when you get a number, you must find possible square roots that go into it. We can apply this to the problem square root of 81m to the third. The first step is to factor 81 into the smallest squared number. The basic perfect square roots are used 1, 4, 9, and 16. So first what we want to do is we want to take 81 by itself and we want to break it down into square roots. So one of the easiest square roots that you can find that go into 81 is 9. So essentially 9 squared equals to 81. So basically now we're going to start using the half power method. So in this parentheses we're going to put 9 squared. I'm going to get to the rest later, but let me show you how to do m to the third power. So basically, you want to split the m to the third power into two parts. So if it's odd like this one, you want to have m squared and m to the first. You can never, if it's going to be m squared, then it's just m squared. But if you split it into two when you always split this into two. So
when it's odd.
Yes, that's right. After we get these two numbers, we'll put this in to this half power method, parentheses, so m squared and m to the first. So the reason we do the half power method is because basically when we power it by 1/2, it's essentially the same thing as square rooting, because square rooting is also you just put into half, right? So you just put in, do the half power method. So you multiply each of these by 1/2, so you'll get 9 to the first, which is essentially just 9. Then m to the first, and then you get for this one, m to the half. So after you do this, basically you want the numbers with the power of 1 to be on the outside. So you have these two, 9 and m have the power of 1, so you'll have 9m here. And then with m to the half, you want the ones with the half to be on the inside. And this is your final answer, fully simplified. The next problem we will complete is quite similar to the other one. It is square root of 8 over 3 and the third power. Now, if you remember what we did before, basically, to make it easier for yourself, put this in the square root and this in the square root, as it's all technically in the square root. Now let's multiply the numerator and denominator by the denominator. So it's square root 3n to the third times on the numerator square root 3n to the third. So if you multiply these two together, what will happen is you'll get square root of 9n to the sixth, and if you unsquare that, it just becomes 3n to the third without a square root. Now, since these two are in the square roots, what you can do is multiply them together like any other number. So 8 times 3 is by the way, it's on the square root, 24 n to the third. Now, we have this answer, but we have to go simplify the numerator. So, we're going to take 24 n to the third, and like we used from other concepts, we're going to take the 6 and 4, which can break into a square root. What we need is exactly what we need, and a 3 and a 2. We don't need a square root here. Remember, this is to the first. So now we want to use that half power method that we were using. I'm not going to get to n to the third yet, I'll get to that later. So we'll put 2 squared times 3 to the first times 2 to the first. You always want to put the first even though it just equals this number. So right now we have that in the square root. Now remember what I said you have to split the 3? Thank you. You have to split the 3, so it'll become n squared and n to the first, right? Because you have to split it. So then we'll have in the n part n squared n to the first, and all of this will become a 1/2 because it's essentially the same thing as square rooting it.
Is we have a half power, a half power, and a half power. And as we know, the half powers go on the inside in the radicand, and the ones with to the first power and higher go on the outside. So we're just going to do that right now. All the ones on the inside, I have a 3, I have a 2. I can multiply these together because they're the same exponent to the same value power. So I'm going to get 6, and I look and I see I have an n to the half power, and I just stick the n,
Perfect.
the end of it, and then what I see, I look and I see which ones are to the first power and higher, and I see, oh, I see a 2, I see an n, so I'm just going to stick the 2n over here, and now Will's going to explain the rest of the problem.
Okay, so remember, this is your numerator. I just want to recap. And so this will be your numerator. This is basically just this, simplified. Perfect, right? So now put it over 3n to the third. And now what you want to do, see? You have an n on the outside, an n here. So you can simplify it even more. Cross out the n, cross out the n, not the cube, just the n. And it'll equal, as a final answer, 2 square root 6n over 3n to the second. And this here is your most simplified answer. I'm Will,
And I'm Ben,
and we'll catch you next week on
Dan the Math Man Tutorials.
Thank you.
Thank you for watching.